is Chantal, and I'm going to be explaining Charles's law and how it was discovered with an experiment with two balloons. The scientist whose experiments led to Charles's law, his name was Jacques Charles, and it was discovered in the 1780s. So he got the idea to start these experiments from hot air balloons, and he wanted to figure out how they worked and why they would float. While studying the balloons, he found the directly proportional relationship between the temperature and the volume of a gas. He was the first person that was able to fill a hot air balloon with hydrogen and fly solo. Jacques Charles did experiments around how the volume of a gas depended on the temperature of it. However, he was not the one who published his work, and he was also not the first person to think of this idea. Guillaume Amontons was a scientist who did experiments surrounding the same topic about 100 years earlier. Joseph Gay-Lussac was actually the scientist who published the experiments surrounding the relationship between volume of a gas and the temperature, but his experiments had definitive measurements and exact numbers, but he did give credit to Jacques Charles. So even though Jacques Charles wasn't the one who first thought of this idea or was the one to publish his experiments, he is still given credit for the idea that temperature and volume are directly proportional in a gas. Mathematically, his law can be written as... To demonstrate Charles's law, I will be using two balloons. This one will be going in the boiling water and this one will be going in my freezer. I will be using this jar for the boiling water to heat up the balloon and my freezer to cool off the other balloon. So my video didn't show a very dramatic change, probably because my balloons are pretty old. In the next clip, you'll be able to see it shrink slightly. If you look in the bottom right-hand corner, you'll see the red actually come in a little bit. So in this part of the experiment, the balloon expanded, and this can be explained by the kinetic molecular theory. The gas particles within the balloon gained energy by the heat from the boiling water, and this causes them to move faster and take up more space. As they move faster and gain more energy, they hit the sides of the balloon harder, causing it to expand and take a bigger shape. This expansion of the balloon ensures that the pressure within it remains constant. As Charles's law states that if every other variable remains constant, temperature and volume will be directly proportional. Now, when the balloon was placed in the hot water, the temperature increased and so did the volume, so that would explain the swelling. So as temperature increases, so does the volume, and we can see that through the swelling of the red balloon. Now I'm going to cool the blue one off and it should be smaller, so I'll put it in my freezer and then we'll see what it looks like in a couple hours. So the balloon's been in the freezer for a couple hours and we're going to compare it to the size of the original balloon. So if I show the freezer, we can see that it is very different in size from what it started off as, and the actual edges of the balloon have slacked and have crinkled inwards because of the gas particles losing energy and coming closer together. So in this part of the experiment, the opposite happens. We place the balloon in a cold environment. This caused the gas particles to lose energy. When gas particles lose energy, they draw closer together and don't move and spread as far apart as they would if they had more energy. So as they draw closer together, the edges of the balloon are gonna shrivel and shrink and not have anything to hold them out. Because the balloon shrunk, the pressure within the balloon remains constant. And as Charles's law states, that if every other variable remains constant, temperature and volume will be directly proportional. Just with the second balloon, it was the reverse. Instead of the balloon being hotter, it was colder, and as we see, that when it got colder, the particles drew closer together with less energy, so the balloon shrunk. So as temperature decreased, so did the volume. So thank you for watching, and I hope this helped with the understanding of Charles's law.